Hello, Facebook fans and YouTube fans of DX Engineering. It's Thursday afternoon here in the Eastern time zone of the USA. It's 1830 Zulu on November 4th, 2021. This is the Manufacturer's Showcase, brought to you by DX Engineering. And this is a show where we feature one of over 160 different amateur radio manufacturers that we represent, that we sell. And so today, we have a very special guest. It's Ward Silver, N0AX. And Ward, your book, it's out.
Amazing.
The second edition, it is out. But hey, Ward, before we start talking about the book, what the heck is going on with the sun?
Well, we wanted a new sunspot cycle, and we got it. So the rising edge of a sunspot cycle is always fraught with peril and has more storms and eruptions, and just imagine yourself getting woken up after 4 or 5 years. Yeah, crabby, right. All that kind of stuff. It happens a lot on the leading edge.
So this morning, the K index was what, 7, something like that.
7, yes. And you know, the big
bands were wiped out.
Wiped out. Two things happened. There was the Halloween solar storm that got a lot of press coverage and then sort of petered out. It wasn't all that big because the CME didn't really smack us a good one. It sort of hit us with a glancing blow, and that was good for the DX contesters who didn't get wiped out, but everybody kind of wandered off and lost interest. So on this one, there was some flares, and then all of a sudden, a thing called a cannibal CME. Oh, what a great term. Cannibal CME is not a bomb cyclone, but it's close. All that means is more than one big eruption of material from the sun came out, and then due to speed differences or magnetic field entanglements or whatever, the clouds that were originally separate kind of merged, and the merged CME smacked us a good one, I believe is the technical term. So we went from 0 to 7 in a matter of a few hours as far as the K index goes, and unless you're a real ionospheric scatter guy or aurora, that's a bad thing for propagation. And I think it's been 7 or 6 now for several measurement periods. So this is a good storm. I think it's a G3.
Right. And so I just saw the K index is down to 3 now. So you know, things are recovering, and
will.
You know, and things will get back to normal shortly. But let's get on to grounding and bonding.
Okay.
Second edition. The first edition was very, very popular, and but the second edition, what's new? Why the rewrite?
Why the rewrite? Well, after the first one came out, there was a lot of correspondence. I happen to have a short list of things here. Would you like me to put it on the screen? Yeah, all right, let's see how it goes. I'll share my screen, and I will show a window. I see and what I want. Let me try this. Nope, you're just seeing. Let me try something again. Thought I had it down pat, but I guess not.
Yeah, you highlight the box, click on it.
Okay. Hang on a second. It's only letting me share Chrome here, Tim. I'm real sorry. I thought this was, anyway, let me start this on my end and then jump back over and let's see what happens. I don't want to waste your time or the viewer's time. Nope, it's just not having it. Oh, there we go. There. Okay, you should see it now, correct?
Yeah. Yep.
All right. Pardon, I apologize for the delay. So new stuff, what's the deal?
Yeah, click on from the beginning.
I did. And here we go. You should see a slide called Conversations with First Edition Readers. Yes?
No. Well, we see grounding and bonding for the radio amateur new stuff.
Okay. Well, let me go back.
I do see your screen, which is a good start, but it doesn't look like.
Okay. Hang on a second. All right.
Here we
Let's
go.
just do this. Okay. There.
Can you click from the beginning so that?
Yep. There's the beginning slide. Do you see it?
Yeah. It's not full screen, but that's okay.
Okay. Do you see Conversations with First Edition Readers?
Yes. Yep.
All right. Sorry about the screw up. So after the first edition came out, boy, did it generate a lot of conversations. It was good to have all the information in one location, and people gobbled it up. And as expected, they had a lot of questions. If I give a presentation on this to a club or something, I'll spend about half as much time answering questions and discussing definitions and things as I will giving the presentation. One of the primary questions was from people who had, quote, upper floor stations, either actually on an upper floor in a house, or maybe they had a condo or apartment, whatever. They were not at ground level or in a basement. So what do you do? How do you ground this stuff? Where should I run my cables? These are all important things, particularly for lightning protection. And so I got lots and lots and lots of questions, emails, phone calls, you name it, letters. And so, as I say in the book can't be a cookbook to answer everybody's questions. It's sort of a toolbox. So there were a lot of questions about how to use those tools. Another topic that was of primary interest was the single point ground panel, or SPGP, that the book describes. And I think a lot of readers were familiar with the idea of an entry panel, where you had connectors and whatnot to route cables through a wall. But the whole idea of a single point ground panel and how all of the protectors, including your AC power, need to be connected to it, and the overall connection within your antenna system, that was a new kind of an idea. So there were a lot of questions. That got things started. So then I went on to say, okay, well, we really need to supplement the discussion of these topics that are generating a lot of interest. What else is out there? So we added a big section on mobile stations. They've been mentioned in the previous edition, but Alan Applegate, K0BG, who's got a great website, k0bg.com, did a big section on grounding and bonding in mobile stations. And then the explosion in portable station activity, it's more than just field day anymore. We've got parks on the air, summits on the air, islands on the air, you name it. What do you do when you have a portable station? What about grounding and bonding there? And transient suppression is of interest as well, because you're using these components to clamp down on voltage transients. What's the difference between a gas discharge tube and an MOV and a transorb? So now we've got a big section that explains exactly what these.
You want to go ahead and advance your slide board?
Sure. Well, I did. It says newer, greatly expanded topics. Are you not seeing that?
No. Can you also try down at the bottom? That now it's there.
Okay.
Down at the bottom, and click on the slide show little deal there in the bottom.
Okay, I've got a little window.
It should the slide deal down there.
Slide 3 of 4.
No, that's okay. Never mind. But
okay.
Go ahead.
All right. Well, let's just stay with this view. So mobile stations, portable stations, and transient suppression. Plus, there's always a lot of interest in the use of ferrite chokes in your station to combat not only common mode RF current, which is what causes RFI, but noise. How do you reduce noise in your station? So those were basically new topics or greatly expanded topics in the book. Then finally, let me page down here. We also worked on existing topics that are in the book. Lightning protection got a real going over. A lot of questions indicated that we hadn't explained things clearly, or maybe the drawings weren't clear enough. And so my reviewers, primarily Ron Block, NR2B, and Dale Svetnoff, WA9 ENA, really dug in on the lightning protection. And Jim Brown, K9YC, also jumped in there. And so we've got a lot more information on how-tos and whys for lightning protection. Then the station antenna system, it just wasn't really clear that everything in your station, particularly on HF, is part of the antenna system. So that's all been expanded and hopefully is more clear. Ron took it on himself to educate me another couple of levels about the subtleties of the single point ground panel, how it actually works, and the idea that everything has to work at the same time was new. So we expounded on that, and hopefully that'll explain why the single point ground panel needs to be constructed the way it does. There was a lot of opportunity for improved and clarified graphics in the book too, so we added some things, we added some new drawings, we corrected a couple of things, but mostly it was just a clarification exercise. And so that's why the book is a little bit thicker and a little bit longer, and has some good new stuff and some better explained old stuff. I think everybody will get plenty out of it. Back to you, Tim.
Okay, yeah, you can go ahead and stop the share. And if you have a question for Ward, now's a great time to put it in the chat. And of course, Ward is well versed on a number of topics. So while we're waiting for some questions, Ward, you know, when I talk to clubs, I give basically it's one of the talks you gave at Contest University about grounding and bonding, and then I tie in some photos of how that's done here at K3LR, which is exactly out of your book, and get a lot of questions about the RF ground planes, right. And especially the RF ground plane with the second floor folks that are up,
yes,
you know, well above ground. You want to talk a little bit about that?
Yeah, as a matter of fact, I'm sitting right next to such a thing. Here, let me point this over. You can see my station. You can see the ground plane right there on top of the shelf.
Yep.
All that. So I live and work. I walk the walk as well as talk the talk on the second floor stations. When we talk about an RF ground plane, I try not to use RF ground, but an RF reference plane is how I talk about it in the book. You're not going to really ground anything at RF except maybe at over a narrow range of frequency. So the idea is to establish a common reference voltage under your equipment or on your equipment, whatever. So the idea is to minimize the voltage differences between over here and over there so you don't have current that wants to flow. Everything goes up and down together. That's the important thing. If you've got an operating desk or operating shelves or what have you, you can use almost any kind of a metal surface to do that. Maybe you even have a metal desk. Some people have used racks from the restaurant industry or something like that. A metal mesh works well. I know DX Engineering sells some really fine business copper stuff. If you've got a really long desk with lots of pieces of equipment, you might want to consider some copper flashing or aluminum flashing, and just tie it down under the equipment, set your equipment on it, and then create some kind of a bus, connection bus, either directly on that metal or use a piece of pipe or aluminum angle so that you can put your ground wires from your equipment enclosures to this ground bus. And then that ground bus has to be tied to your single point ground plane and then out to the ground if you have an external ground wire. If you're on the second floor or third floor, that ground wire isn't going to do a lot for you because it's got so much inductance. But you can run one out there anyway at very low frequencies. It will help. And that's also got to be tied to your AC safety ground.
Right.
But the basic idea is just to create that common voltage reference under your equipment so everything goes up and down together.
Right. And of course, that's explained here in the book, how to install the ground plane, how to connect it up. And there's some really good drawings in here about that as well. And Scott, KE5 Oscar Lima, says, my station is on the second floor. If I were to run a ground wire, it would be about 25 feet to get to the outside for grounding. What are my options for ground wire? And Ward, as you just mentioned, there's a lot of inductance with that. And so my suggestion would be the 2-inch wide copper strap.
Yeah.
That's the lowest amount of inductance you're going to get for that kind of an installation. And then you got to make sure you get really good connections to the ground rod. And I like to silver solder right there, take that strap and silver solder it right onto the rod.
Yeah, there are also clamps that you can buy for that. And as I caution people, soldering will work if we're just talking about minimal amounts of current. But if you are putting solder in the path of a full lightning strike, it'll vaporize. Oof, even silver solder. So you don't want to do this at your ground rods at your tower. 25 feet is too long for it to be an effective ground above a few hundred kilohertz at best. But it will help connect your station to your perimeter ground or ground rod, which must be connected to your AC service panel ground rod outside the station. And that's an NEC rule. All external ground electrodes, whether they be rods or the UFA ground or whatever, shall, the word is shall, meaning you gotta connect them together. And that keeps all of your ground systems going up and down at the same voltage too. You don't want one set of grounds going to a high voltage and another one to a different voltage during a lightning strike. That's bad. But go ahead and run a ground wire out. If you can't do the 2-inch strap, you can use copper pipe, which is good, not that expensive. You can use refrigeration tubing, which is not that expensive, and it's also sold. It's not as expensive as per foot wire or strap because it's a kind of a high volume application. Or you can just use a good old piece of number 10 or number 8 or number 6, whatever. Good, heavy, round wire, piece of strap, piece of pipe.
Steve, NA5C says, what if there was absolutely no connection to ground, i.e. remove the third pin on AC plugs, insulate the tower base, then there would be no path to Earth?
Ha! Lightning comes from 50,000 feet or more up in the sky. Do you think it's going to say, oh, there's no connection here. I got to go back. I'll go hit something else. Nope. All you're doing is giving lightning a totally free hand to go wherever it wants to whatever it thinks is handy. That's called an air gap. And lightning will cheerfully jump the air gap and go places you never expected it to go. And so do not do this. Do not think that you can isolate your ground systems against lightning. Will not work. So tie them all together so that everything goes up and down together. That's why it's in the NEC to do that. Thousands and thousands of hours and millions of dollars of damage have been examined. And this is how you protect yourself.
Right. And you stress in the book, Ward, that you want to try to help lightning make good decisions. And the first thing is to keep it outside.
Right. What does lightning want? It wants to get to the Earth. It wants to dissipate charge or, equalize charge imbalances between the Earth and the cloud. So to do that, let's assume the charge is coming down. You want to make it easy for lightning to disperse into the Earth. So give it those heavy low resistance, low inductance, low impedance paths into the earth as much as possible. Some people even put radials out from their perimeter ground system so that lightning comes down and it looks at what you got and it's going to hit it and said, I want to go to the earth. So make it easy for it to go to the earth outside. Don't run your ground system through a crawl space or a basement. Everything needs to be connected outside.
So Andrew, Victor Kilo 4 November, Mike said, I once had a close proximity lightning strike. Coax unplugged, but the radio was grounded. Repairer said that it traveled via the earth stake to the radio. Was this true?
It went from the earth stake, meaning ground rod in America, to the radio, to something else. Okay, so it's the current that does it, and the current has to flow through something. So either there was an induced lightning surge in the feed line that, or in the ground wire that came in and induced enough voltage in the radio to pop the input. I assume that had damage in the radio. It could have been through the ground, through the power supply, through the AC service, any other connection. It will cheerfully come through. It doesn't matter which way you expect that current to flow. If the voltage says flow from the earth to the radio, it'll happen. So the idea is to make sure that everybody goes up and down as close to the same voltage as possible so that the current doesn't have a reason to flow through your radio on the way to any place else.
Ryan says, I have a fold-over mast that I use with temporary antennas attached to a pallet. What should I do for grounding the mast?
I'm not sure what a pallet is, but okay, so you've got a temporary mast. If it's like a portable station, there's not a whole lot of benefit to going to a full ground rod or anything if you're just going to put it up and take it down. If you have one that's more permanent, I would ground it like any tower, and I would use a ground rod, and I would bond that to the mast. And then if the mast is close to your house or your perimeter ground system, meaning less than 50 feet or closer, then run some number 6 or whatever between your ground rod and the perimeter ground system. And that helps keep everything going up and down together.
And I do have to say hello to one of our CW operators here at K3LR. VE3RA is on. And Ed, great to hear from you, and hope all is well up there.
Hi, Ed.
And also Radio Alpha 2 Fox Zulu before he was VE3RA. So Ed is well versed in Russian as well. And let's see. That's all the questions we have. Ward, thanks so much for coming on. It was great to discuss the sun with you. And I got to tell you that I rebuilt the entire perimeter station here this past summer, and really paid attention to all the things that you have in this book. And I got some really nice compliments from the operators last weekend about how low the noise is, how well the isolation is, and it's all about bonding. Yeah. And I've got good connections to ground, don't get me wrong, but I've never had such intricate focus on making sure that the bonding was done perfect, and it paid off. So
that's a good thing. And I got to tell your watchers that you think, oh, I got a small station, I don't have to worry about this. No, this is exactly the right time to do it right. You're starting a new station, you're going to add a box or two, something like that. Take it all off the operating table, lay down that ground plane, and put it all back. And it'll pay big benefits. You'll have less RFI in the shack. You won't have those hot spots that always seem to be at an unpleasant point that you can detect with the most sensitive parts of your nose. These things, do it right, do it once, and you'll never regret it. And even at a big station like Tim, there's a dB is a dB is a dB. And if you can grab the dB of noise reduction or isolation or something, it does pay off.
And I found the section where you really go through the ferrite applications fascinating, and it's great information. And I know you worked with Jim Brown on that, and that's just good stuff.
Go to K9 Yankee Charlie, K9YC.com, and click on his publications link. There are great white papers there. His tutorial on ferrites, it's called RF. Look for the RFI tutorials. It's just a treasure chest of information about ferrite, how to use it, what parts to order, what works, what doesn't, why the different mixes, what does that mean? It's all in there.
Great. Ward, thanks so much for coming on today, and we wish you continued success, and we'll see you the next time. And everybody tune in tomorrow afternoon. It'll be the weekend special, the Friday before Sweepstakes CW. It's going to be a good one. So we'll see you at 22.
Yep.
There we go.
All right.
All right.
See you. 73.
Ward, and 73 to all the viewers, and we'll see you next time. 73 from DX Engineering.